In this video, we're going to take a look at interacting with the environment in our hooked Syscall. So we're building this in Rust. It's an EDR, so an endpoint detection response system, basically antivirus and steroids that kind of lives in the kernel and lives in user mode and injects itself into other processes. So if you've been following along, fantastic. This is my blog, go check it out. If not to worry, go and probably have a read of that before getting into this, because we're starting to get into the meat of what it is we're trying to do. So this open process here is our kind of, you can think about it as a callback function. We alter the flow of execution from where the syscall lives in Windows in NTDLL from open process, and instead we jump to our injected DLL so that we can start having a look at what this process is doing. So the first thing to note here is we have the assembly macro down here, which is essentially going to make sure that these input parameters to open process, or really to ZW open process, get reserved. The compiler is going to worry about the issues of putting these on the stack or putting these in other registers to make sure that we do have them available here. Doing this ourselves would be really nasty. We would be fighting with the compiler unless we just flat out put them on the stack, but then that of course introduces other issues and complications. So let's work with the Rust compiler and use the ASM macro. And just above it here we have a little thing that checks whether the client ID is null, which is always nice to do before dereferencing something. And essentially what we're going to do is we're going to open a message box that you'll see in just a second, which is going to print the unique process, which is a handle attribute to the window, and it's also going to print the process handle that's one of the other input arguments to ZW open process or NT open process. So we have the user mode engine running, we have the GUI running, and we have the driver running in the kernel as well. So everything's set up, good to go. We have our debugger, and what we're going to do is we're going to launch malware.exe. What this is going to do is it's going to try and get a handle to Notepad, and it's going to print out the result, whether that was successful or an error. Of course we want that to be successful, which means that our redirection of control flow hasn't messed up anything under the hood in how the process works, because the last thing we want to do if we're building an EDR is cause system instability and have a CrowdStrike moment. No thank you. So let's go and run this. Now we're going to get this little pop-up which just gives us a moment to attach ourselves to the process, and what we can probably do is just have a look at ZW open process. And so we do have a breakpoint there. I'm going to unset that because that's not actually going to trigger. So this hasn't yet been patched, and that's okay, because we've broke before that point essentially. So let's go and look at sanctum.dll, and of course we have the open process symbol here. So this is the optimized build, so the release build of the DLL. So where we were just looking here, this is exactly this. I've built it in release mode because it's a little bit easier to follow when looking at the source code with the assembly, or with the generated assembly. So first of all we have this here, so we're going to check if client ID is not null. If it's not, then we're going to do this stuff and open the message box to show us the data as the user. So looking at this here, we have your sort of prologue, and then we have this test R9. Now what's going to be in R9, we have a breakpoint here we can set, is this is going to be that parameter. It's going to be the client ID parameter here, because of course it's the fourth parameter, so you've got RCX, RDX, RA, R9. So this is going to test if it's null, if it's 0. So if it's not, then we're essentially going to start doing this, and you can see down here message box A, so that is here, much clearer to see in release mode. And then what we get to is we see the syscall here. So you can see here that we move in something from the stack into RCX, and then what gets reserved in registers 15 and 14 go into R9 and R8, so on and so forth. We move the system service number 26 into EAX, move RCX into R10, and then we make the syscall. So comparing that over here, you can see move R10, RCX and syscall are the only two kind of manual commands, if you like, that we type, because the Rust macro, the ASM macro, is going to make sure that at the point this runs, these registers are set up correctly. So, and this is kind of what I meant before around making sure these are preserved. So here we can have a look at what goes into register 15. So the general purpose 15 here is R9, which, as we saw, was the client ID, that fourth parameter. So if we go back and have a look over here, that gets moved. So we're just making sure that we preserve everything without messing up the stack or the registers. Because if we were to write this to, let's say, we manually write this to register 14, and then Rust goes and clobbers that by putting something else in register 14, all of a sudden we're in a real world of pain. So that's probably enough talking. Let's go and just resume all of these, so we can click OK. So what should happen now is we should break. Have we set a breakpoint? I don't remember. So we have a breakpoint here. So let's go ahead and run to that breakpoint. So we're going to click OK, and we're at the breakpoint now. So if we, in fact, we're probably better actually breaking here. So we're going to continue running until there. So of course now we have the pop-up, so the instruction pointer for that thread is here. So we can see that we do have, I think that was the client ID. Parameter in this one here is the handle that gets passed in as the first parameter. So if we click OK, we're going to break next just before we make the syscall. So looking at the parameters, we have hex 26 in RAX, which is our system service number. RCX, RDX are set up correctly, and we have R8 and R9 over here. All is good, and then if we just step through, we'll see the change there. Put in RCX into R10 as well, so you can see that ends 3F8, 3F8, perfect. So 26 is currently in RAX. Of course, we're going to now make the syscall, which is going to pass execution into, but it's not going to pass execution to the kernel, but it's going to ask the kernel to do its thing, and it's going to give us a return value. That return value is going to go into RAX by convention, and this is going to be, I think it's an NT result, so it's going to tell us whether it succeeded or whether there was some kind of error, such as invalid arguments or a null pointer or something like that. So if we go and step over that, we can see that in RAX now the result is 0, so that's that indicates a success. Now over here we haven't printed yet what the result of that was, whether we successfully got the handle. We know from looking at this register that it did succeed. So what we're going to do is going to just continue execution over here up until the program hits the loop. So if you go and have a look at the malware, you can see that it's going to make that open process request, then it's going to print the result, and then it's just going to loop, just so we can keep the debugger attached if we wanted to go and inspect anything else. So where are we? Let's go and hit run. So that's going to continue execution, and we can see here open process result was okay, and that's the value of the handle. So everything worked out just fine. I hope that was enjoyable. I hope you learned something. I've certainly learned something here, which has been really fun. If you like this video, go check out my previous, or go and have a look at my blog, or give this project some love on GitHub. If you've got any ideas, suggestions, contributions, anything you'd like to see an EDR do, we'll build it together. I'm going to document sort of all of the more detailed technical kind of parts of building an EDR. There's probably a few more blog posts already that I need to write around driver development and everything else that we've done. Please let me know. I'm really curious, and I hope you enjoyed that, and I'll catch you later.